belief isn't rooted in fact. For example, I can believe that the sky is green, but that doesn't make it true.
Well, what if I told you?
Beringia was not a bridge, but a homeland twice the size of Texas, inhabited for millenniums by the ancestors of the first people of the Americas. Popular theory of Native American origins debunked by genetics and skeletal biology. Latest scientific findings suggest the ancestral Native American population does not originate in Japan as believed by many archaeologists. This was done in 2021. A widely accepted theory of Native American origins coming from Japan has been attacked in a new scientific study, which shows that the genetics and skeletal biology simply does not match up. Now, we all understand human migration, right? And Homo erectus, which is where Neanderthal, Denisovan, and Homo sapiens come from, started in Africa. They were potentially the ancestors right before the Homo sapiens, which is us. As far as what species can stay alive the longest for generations, yeah, Homo erectus takes the cake. So far, the species lasted over 2 million years. In comparison, the Homo sapiens read about 200,000 years. But we're still running our numbers up. We ain't done yet. But check it out. The Homo erectus is also known as the upright man. Why? Well, because they were the first to mark an important transition in posture to bipedalism. Yeah, there's a lot of benefits there. Another remarkable achievement is they were the first to control fire. They were also the first to live in a hunter and gatherer society. And all of these people started migrating out all over the world. And as all of these people migrated and settled new lands, their genetics changed to the environment in which they lived. They created new cultures and traditions for themselves. Their languages changed over time, which started making them culturally and physically different from the people in Africa.
DNA studies show our earliest ancestors may have first appeared in Africa roughly 200,000 years ago. But around 50,000 years ago, in the throes of an ice age and severe drought, several groups were driven out in search of food. One group followed the coastal areas of the Indian Ocean. Around the same time, a second wave of migration headed north, splitting somewhere in the Middle East to sweep into Europe and Asia. These first members of our extended family were on their way to populating the globe. As they migrated, met, and mated, our early ancestors left a lot more than fond memories behind. They left a bit of their DNA. Scientists have used that DNA to trace our roots back to the oldest population in the world, the San Bushmen of Africa. Here's how they did it. DNA often develops small glitches in its sequence. These inherited mutations are called markers. In the case of males, the Y chromosome passes unchanged from father to son, and so do its markers. In females, mitochondrial DNA is inherited solely from the mother. Its markers can be used to trace a female's genetic trail. So male or female, scientists now have the power to reconstruct our entire family tree as far back as the oldest human remains we can find, as long as they can get a pinch of DNA.
So regardless of where our ancient ancestors migrated from, we are no longer those people and haven't been those people for thousands and thousands of years, at least 25,000, but most likely longer. But if we use your logic that says that we are Asian or we are Siberian, then that would mean we are African, which would make you African, since all Homo erectus originates from Africa. So again, we know when people have settled lands for thousands and thousands and thousands of years, we change genetically, physically, culturally, and linguistically. Therefore, we can conclude that my people are not African, my people are not Asian, and my people are not Siberian. My people are the original people of these lands. My people are indigenous Americans, and our genetics prove it. Have a day. Beringia was not a bridge, but a homeland twice the size of Texas, inhabited for millenniums by the ancestors of the first people of the Americas.
They don't have what we have because we are indigenous. We are of this land. And we're the only ones that can say that. We're the only ones in this country that can say we are never homeless. Houseless, yes, at times, but never, ever homeless. We are of this land. So land back is that carries a lot of history and a lot of hope. So I love that saying, land back.
This is Beringia, a vast landmass surrounded by ice that connected Asia and North America. Long glacial periods have caused sea levels to fall, which formed and reformed Beringia many times over the past 2.5 million years. But to fully understand the formation of this region, we must pull back. Not just back in time, but in space. 3 planetary orbital fluctuations, called Milankovitch cycles, affect how much solar radiation reaches the Earth. These change the shape and distance of our planet's orbit around the Sun, the angle the Earth is tilted towards the Sun, and the extent to which the Earth wobbles while it spins. Each cycle has its own timing, which creates alternating climate cycles here on Earth. Depending on the timing and the position of our planet, these cycles warm or cool our climate. Glaciers grow during cooling phases, especially in the Northern Hemisphere. During the Ice Age, this occurred many times. But how do glaciers form? Glaciers are created when large amounts of fallen snow compress over long periods of time into thick, dense sheets of ice. Glaciers grow and melt every year, but when they grow faster than their annual melt and continually expand, the process is called glaciation. Beringia avoided glaciation because high mountain ranges blocked precipitation from the Pacific, creating rain and snow shadows. During these periods, the entire Arctic Ocean was covered in sea ice, which also helped keep Beringia cold and dry. Ocean depths closer to land are relatively shallow due to continental shelves. During the Ice Age, so much water was locked into glaciers that sea levels receded by as much as 120 meters. This exposed the continental shelf that connects Asia and North America, forming a land bridge. Today, much of the land bridge is only about 80 meters underwater. Land bridges formed elsewhere on Earth. The British Isles joined mainland Europe. The various islands of Southeast Asia were linked. Australia was also connected to its surrounding islands. All of these required broad continental shelves and were critical for dispersal of life between continents. With the continental shelf exposed between Asia and North America, the land became tundra and dry steppe grasslands. Animals adapted to this environment began moving between Asia and North America across the land bridge. Glacial cycles determined what types of habitat existed. During interglacial periods, when climates were warmer and wetter, the Bering Strait was flooded by rising sea levels, and animals adapted to boreal forest conditions prevailed. During glacial periods, when climates were colder and drier, grassland environments developed and grazing animals adapted to a steppe tundra environment were more common. Humans lived in western Beringia for thousands of years. But starting around 20,000 years ago, humans began moving across the land bridge towards North America. By 14,000 years ago, they had established sites as far eastward as the Yukon, such as the Britannia Creek, Bluefish Caves, and Little John sites, sometimes within only a day's trek of the ice sheets. Toward the end of the Ice Age, the continental ice sheets began melting. These meltwaters formed huge glacial lakes with a network of drainage systems that are still evident today. The meltwaters reached the ocean, and over the next few thousand years, seas gradually rose and once again severed the land bridge. A drastic change in vegetation began as the environment transitioned into the modern boreal forest. Many animal species, such as woolly mammoths, that were adapted to the glacial steppe tundra conditions disappeared. Today, the Kluane or St. Elias ice cap is the largest remnant of the Cordilleran ice sheet. Outside of polar regions, more glacial activity remains in this region today than anywhere else in the world. The many cycles and environmental factors that have led to Beringia's many formations and declines shows us just how dynamic Earth's climate can be.